Hello guys, how are you doing? I hope you are having fun because I'm feeling good at the moment. You want to know why? It is because we will be learning about Pythagoras' theorem. Pythagoras was a Greek philosopher and was very knowledgeable. The theorem we are about to discuss is widely attributed to him, although historians have some doubts with regard to his being the one who originally came up with the theorem. The theorem can be stated that for any right-angled triangle with the length of hypotenuse given as C and the lengths of the other two sides given as A and B respectively, the square of the length of the hypotenuse is equal to the sum of the squares of the two remaining sides. The theorem holds for all right-angled triangles and can be seen in this illustration. If squares are extended from the sides of this triangle as shown on the screen, and we find the areas of all the squares, the area of the square with size 3 units will be 3 times 3, which is 9 units squared. The area of the square with size 4 units is 16 units squared. And the area of the square with size 5 units is 25 units squared. We can see that the square is drawn from the hypotenuse. So if we sum the area of the squares in the first two cases, we will see that it gives us the area of the third square, that is 9 plus 16, which equals 25. That is exactly what the Pythagoras theorem says. The Pythagoras theorem is relevant in many fields in maths, especially for finding the length of a side of a right-angled triangle when the lengths of the other two sides are known. For example, in this triangle, the length of the hypotenuse is 5 and the length of one of the other sides is 3. We can use the Pythagoras theorem to find the length of the third side. Remain with me as we do this together. The theorem states that c squared is equal to a squared plus b squared. And we have c, which is the hypotenuse, to be 5, and one of the sides, which we can label a, to be 3. We can conveniently label the unknown side b. Note that the letters a and b can be used interchangeably to represent the other two sides of the triangle, which is not the hypotenuse. So, plugging the values into the equation, we have 5 squared equal to 3 squared plus b squared. We will continue by doing the squares to get 25 equal to 9 plus b squared. Now, we collect like terms on one side of the equality sign. We can do this by subtracting 9 from both sides of the equation to get 25 minus 9 equal to 9 plus b squared minus 9, which gives 16 equal to b squared. This is the same as b squared equal to 16. Now, to find b alone, we have to find the square root of both sides, which will give us b equal to 4. Great! That is how Pythagoras theorem is used to find the length of a side of a right-angled triangle from the length of the other two sides. We can also use Pythagoras theorem to check if a triangle is a right-angled triangle. An example is this triangle with sides 2, 3, and the longest side being 6. To check if the triangle is a right-angled triangle, we assume the longest side, which is 6, to be for the hypotenuse C, and the other length to be for the two other sides. Then, plugging the values into the Pythagoras theorem and comparing the results on both sides of the equality sign, we will see whether or not they satisfy the requirements of the theorem. So, c squared equal to a squared plus b squared becomes 6 squared equal to 2 squared plus 3 squared. Doing the squares, we get 36 equal to 4 plus 9. And going further, we get 36 equal to 13. This, as we can see, is obviously not true because 36 is not equal to 13. So the triangle is not a right angle triangle. In summary, we have learnt the following. 1. What the Pythagoras theorem is all about. 2. How to use the Pythagoras theorem to find the length of an unknown side of a right angle triangle. And 3. How to use the Pythagoras theorem to check if a triangle contains a right angle. Remember that you will only get better by practicing more. It is always so much fun learning maths with you. See you next time.